Okay, I haven't made a video for a long time. I feel horrible about this. Maybe you're thinking I'm dead or something. Maybe hoping. Now this video I'm gonna make about Monte Carlo simulation and how you could, in theory, I emphasize in theory, use Monte Carlo simulation in credit analysis. Before let me tell you before can I've got to really bitch. That's what I've got to do. You know, there's this program called the Rainbow Program, and I've been working on this gigantic model. I can't, maybe I'm not supposed to really tell you where it is or anything else. It's, oh my God, it's like 40 megabytes and it's got all sorts of different electricity plants and outages and all that crap. But they say, oh no, if you have a formula, they have this little program for the auditors, and all these idiotic auditors do is run through this stupid little program to say, oh no, you've got 30 in a 30-day month, you put 30 here instead of days per month. Oh no, you put 12 up here for the months in the year because there must be so many other months. So these little things, and then you get a bad score, and then the client says, "Oh no, you got a bad score." What a lot of crap! Oh, enough of the bitching. Okay, let me get back to the subject. Oh, these auditors. So I'm going to talk about a much more interesting experience I had with a man named John. I better not tell him my last name, say his last name. He might demand I bring down the video like I had to do for this Mario for his hydrogen LCOE, which is another fascinating subject I'm going to make a bunch of videos on. But I'm going to go through credit analysis. I worked with John. We had these little hour-long sessions like every day. It was kind of a pain. It was in the middle of the night for me, but we really thought about credit analysis and came up to the conclusion that, at the end of the day, when you just can't take the judgment, you can't make some kind of model, whether it's computing a lot of historic financial ratios, whether it's trying to make a financial projection model, whether it's using Monte Carlo simulation, whether it's looking at other case studies. These things, they're very difficult. Thankfully, you can't put it in a Moody's black box. You have to do some real work. So I'm going to take what I promised to John is that I take some of the stuff we discussed in these very little short sessions and review them further. And the first one I'm going to start with is Monte Carlo simulations, because I got a couple of really, really nasty comments on my I must have made my last Monte Carlo simulation stuff. I don't know if I bitched about it too much or if I criticized it too much, or I made it in the middle of a restaurant and there was a bunch of background noise. And I want to talk, when I talk about Monte Carlo simulation, the key thing is not making a little Monte Carlo simulation in Excel, that's for sure. And the key thing is not counting how many scenarios you have to do to make it all work out. The key thing is understanding, does it come from a normal distribution? How, I think, after being addicted to Monte Carlo simulation a long time ago and then realizing it's never useful really, and hardly ever, it might be one or two occasions when you've got a real option to use it, but very rarely do you find practical, real examples of using it, but it can be used to demonstrate some issues. And the issue I'm going to show you today is okay, we want to get and we want to replicate. These are Standard & Poor's. I even put Standard & Poor's down here. Here's their probability of default. And the probability of default, they say here for where is it? A triple B gets to somewhere, what is that, around 7%, 7% perhaps. And then they say, well, how long does a triple B, where are they? How long does it take before they get to their default position? It looks like this looks like that. This is a log scale, so it's hard. So they give you one table. Now, in the old days, these used to be in PDFs, which are nice, and now you can't kind of get them in PDFs anymore. So this is a 2016 study, and it says, well, the default for a triple B it's let me see, a straight triple B, it goes to 4.79, triple B plus 3.88, and they brag, of course, that this means that they're doing a really good job because the different ratings have a different the lower the ratings, the higher the default, so they're perfect at doing their job and predicting things, and they've got very thousands of people who do it, and everybody should look at them, and that's fine. I'm not criticizing this all. They what I do criticize is man's trip double A. This looks like there's almost no default. The problem is the biggest default that ever happened in the history of the world there. Lehman Brothers was a double A when they started, and that's just like one little default here, and they don't show you there's no weighting of the size or anything. Well, that's beside the point. Okay, so what I'm going to try to do is show you how to do something kind of cool, and I want to show you number one that really, in theory at least, credit analysis is based on the volatility of the cash flows. Now, it's also when we make our model, whether you have mean reversion, whether it's from a normal distribution, whether the mean changes over time, these are enormous issues which basically invalidate really using Monte Carlo simulation. The inputs are so difficult, it's almost impossible to use. I'm going to show you how to measure mean reversion, which is another criticism that I had. So I think that's almost enough of the introduction. So why don't I do this? I've already got this little simple example I worked out, but I'm gonna do it again. The first thing I think I'm going to do, and I might have to do this. Here's this stuff from Standard & Poor's, okay? And if you've got a PDF, and let's just remind what you can do with all this stuff. You paste it special as Unicode text. It comes like that. You could, this one you could do a text to columns. I think probably it would really work. But what I'm going to do, just because I wasted a lot of time, the reason you can do a text to columns on that one is because there are no words really. But you can also just use this one, Shift Control A, uh, and hopefully it's going to all work. I should have tried it perhaps first. Okay, so that's our time horizon, and we have our triple B and our triple B plus. We can let's focus on those. Now, the reason to focus on those is because if you look, I suppose I'll do this in another thing. Whenever I ask a banker, okay, what kind of rating do you have for project finance? Whenever I ask a banker, what's your rating? They say, if I have a rating score of 20, it's somewhere around a 10. If I have a rating score goes from 1 to 10, it's somewhere around a 5. And then if you've ordered my little resource library and you look at this, and then you go to the S&P reports, and I have to go to this last one where we have this nice man, this very smart man, because that was before 2008 when they distorted all their numbers to show how they're still really good. This one, I'm sure I've done this before, and I'm sorry if I'm being a little bit repetitive, but should I do it like this perhaps? You know, This one, triple B minus or triple B, seems to be the big ratings, and this assumes that there isn't a migration of the rating below or above. Of course, there will be, and there'll be some defaults. And these triple A's are these guaranteed bonds. But the target rating is somewhere between triple B and triple B minus. That's why I'm focusing on this. Now, I'm going to make this video, and then the next video, I'm going to use some oil examples and some mean reversion and get a little more sophisticated, and then I'm going to use some non-normal distributions and show you how you can do some of this because of this criticism. I got a really horrible demand that I take my video down on mean reversion. I've got a few really nasty comments about that one. So that's what I'm going to, we're going to look at, we're going to focus on this triple B, and not maybe even the triple B plus. So let's do this, you know, and let's see here, what should we do? What happens if I do this? I haven't kind of tried this. If I select this and press the control key, and then I can't, I can't, ah, shit. Let's do it like this. Let's just shift alternate and plus, and just graph kind of these things. By the way, that stupid goddamn rainbow program, which would be so easy to program yourself. It's bizarre that these auditors seem to like that. Says you're never allowed to hide things. Whoops, I didn't mean to do that. Now I'm gonna screw it up. Shift F11. Okay, and I better select the data, and I better redo that one. And whoops. Oh shit. Okay. Screw this. You don't have to see those years, do you? Let's just take triple B and triple B minus. Oh, you notice my program deleted the minus, by the way, function. So it's not perfect by any means, that's for sure. There we go. So let's see if we can make a Monte Carlo simulation. And if we put a volatility in our analysis, let's say we put a volatility of cash flows and some fixed and variable costs. And of course, for the bankers, fixed cost is a disaster. It aggravates the volatility. So when I had these discussions with John, a lot of the question was thinking more philosophically about this stuff. So I'm going to leave the titles out. We're going to make a Monte Carlo simulation with different volatilities and different DSCRs and demonstrate how you can use Monte Carlo simulation to replicate this. Now, I've been making long videos these days, and I know everybody hates long videos, so whatever, you can kind of skip around them or turn them off, of course. And uh, um, let's just, before we do this, let's also look at some volatilities. Now, whenever I get this data, and I know, I'm going to do some videos on cost of capital, my old favorite subject, which is really dramatically, there's some dramatic things obviously going in the world with negative real interest rates and all of that. But if we look at some of our databases, whenever and I'm gonna let's start with just some oil prices. So if you go to the commodity prices and you go to the one that says come on. Oh, is this, oh shit. Commodity price analysis. What an idiot. Why can't I even find anything? No, these things are making me so nervous. There they have a kind of forecast of the oil prices. And what I've tried to do here is what, so let's look at, let's look at just crude oil, and let's go all the way back. Now, in the next video, perhaps let's go back to, I don't know, maybe the world really changed. So we can't use the volatilities before something like 1973 when this all changed. And then we can look at the distribution, and I guess I put the distribution of palm oil. I guess I did it with the second one and not the first one, huh? So let's do this one. So we can see that it's not normal. We can see that there's a thing over here, and there's a much higher mean than would be predicted. And we have a volatility of 34% in nominal terms, which is enormous. Now, if we look and start and this volatility is the rate of change. It's the standard deviation in the rate of change, and it assumes no mean reversion. Now there's clearly mean reversion going on. When it goes up, it comes down. But the real question is, when it comes down, what's the new kind of average level? Let's go past the 80s when we had these really low oil prices and start maybe where somewhere in the middle of the 1990s. It really doesn't matter, does it? Then we still have the volatility is still pretty constant. This is an annual volatility. Now this is these are computed on a month by month level. So let's use that, and let's see what kind of DSCR we need with a series that has a annual volatility of something like 30%. Let's see what happens if we do it later. Now, you can, of course, get the implied volatility, and people could yell at me. I used to get so intimidated by all these really fancy guys at the bank in the trading floor. Oh, I've got implied volatility from the thing. So that's about, let's use 33% volatility. If you and look at again, look at this is the again, the rate of change. This is what would be predicted by a normal distribution. Look at this. We've got this extreme kind of thing here. This looks skewed to me. So we're going to need to have some adjustments, and using a normal distribution might not be so good. Let's look at something that's even more kind of perhaps has higher volatility. That's natural gas prices. And again, then we have a skewed, or a non-normal distribution, some even higher volatility. Let's look at natural gases in Europe. That should be something like more like oil. It's a little bit lower even. And again, we've got this enormous kind of thing that doesn't look very normal. So please, if I'm going to make this normal distribution, do not assume that do not think that I'm arguing in some cases that it's okay to always use normal distributions. When you look at these biggest bankruptcies, look at this one. This is an energy company. There was a lot of fraud, but there was also some real things going on. Calpine, that's an energy company. Ford, no. Okay, this one is an energy company. This is an energy company. These ones, there might be some mean reversion, and we'll see how bad they really are. This is a political risk, really, the only political risk. Here's an energy company. It's surprising how many of these companies that defaulted are energy companies, and you can see over here that the energy and natural resources has this big default. So now let's get into our simulation and use a volatility of how about I'll use 33%, okay, of our price. Let's let's make some assumptions here. Let's make a timeline. Anytime we do any model, we should make a timeline. Okay, and let's start with 0 perhaps. Alt-EIS, let's make it to be 20 years, or should we make it a little less? This was 15 years. Let's make it 15 years. Okay, and we're going to see what happens. Let me make sure I kind of get the objectives here. So let's go down here and make some assumptions. And we'll put some volatility in here. Of price. And then let's put some volumes. And let's make the volumes just flat. Really boring. But then let's put some variable cost and fixed costs. And I just want to show you something very basic. This is the kind of thing you can do with Monte Carlo simulation, because I'm going to do another video on Air Asia, a case study to see if that companies can survive after this pandemic. Of course, with the pandemic, using volatility and Monte Carlo simulation would be about the most idiotic thing in the world. These are extreme, unpredictable spikes that you could never get modeled with a Monte Carlo simulation. Everybody knows that, and that's a criticism of this, but that's still okay. We'll whatever, do some of that. And then we're going to put the DSCR target. And then we'll put, well, no, let's, so given the volatility, given the level of fixed cost versus variable cost, one thing we do know is that you as a banker, when you're looking at downside, you like variable cost, not fixed cost. You like it when people can fire employees, and you like it that the costs go down when the revenues go down. That's because you're worried about downside risk. That's because, as you know, a debt, risky debt is just like an option. Okay, some of this crap, by the way, that anybody who says that the cost of equity is always higher than the cost of debt has to have their head examined. It's just incredible that these basic ideas are so wrong in finance. But what we're going to try to do is, once we have that, then we're going to get the probability, we'll get the default, and we'll get the probability uh, of default. And what we can really do, here's what we're really going to do. We're really going to try to see, okay, if I want to be this to be a triple B minus, what what kind of DSCR do I need? What kind of target DSCR do I need to put in here to get that probability of default? Okay, that's what John and I were discussing, and it illustrates kind of a lesson number one. Lesson number one about uh, uh, let me, I'm going to do a very simplistic model, violate all my principles, and this rainbow program, these goddamn auditors that who worried about this shit would give me a bad score. It would you would have a bad score on this. You'll have a loan formula, this loan formula they keep on talking about if you put an input somewhere else and all that. Get me back to this. So let's put price forecast. Now, let's say we start in year 0 with 50, and let's put let's see. I'll put 50. I'll put 50 here. Okay, and I'm not going to put units in here really, because this doesn't have to be oil, and this the volumes could have the volatility, or the variable cost could have the volatility, and it's really interesting when you really step back and think about the philosophy of these things. When you really think about the philosophy, whether there's a permanent reduction in the oil price or the fashions for, I don't know, some kind of dresses have changed, or something you have is gone obsolete. Those are real credit risks. To try to put them in some kind of bucket and try to easily say, we can always get this kind of thing, we can mathematically represent this stuff, such a dangerous thing. So I'm going to put 33% volatility. Okay, and let's just make our volumes 100. Okay, and then let's see, if we put a DSCR of, let's say our variable costs are, I don't know, 10%, and we have a fixed cost per unit. Let's put a fixed cost uh, per unit, and let's make our fixed cost per unit 15. And later we'll change this around. We'll change this around. We'll make the variable cost higher or the fixed cost higher, and we'll demonstrate some key ideas that obviously you need a higher DSCR target. Let's put a 2, how about a 1.8 times? Because we got high volatility. I'm going to put a 2 times volatility. Okay. Shift up, 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 up. Okay, and then we're gonna once we do this, then let's do our classic. Let's do our classic kind of model. Oh shit! What am I doing? Okay, and so now for the volatility, I'm gonna assume. I suppose I can do this. I'm gonna put this over here, and then now I don't know. Do I have generic macros open? Yes. So I can press Shift Control R, and then this guy who's, you know, when and these guys say, oh no, press F4 twice. Ooh, that like that. Oh God. They think that's what modeling is about. Or these people, they go like this. If they, whoops, what they'll do. I'm sorry. Obviously, I'm mentally unstable, like some other people. You know that I'm not from the U.S., but I speak with an American accent because I've lived here a lot. Yes, there's some other crazy people around here too. Okay, so if you wanted to do this, the idea is you'd go up, control right, go down to where you were, shift control backwards, and then you can do this really fast. And then you're really proud of yourself. I can't even do this. Instead of instead of my battery isn't working. Shift control. Instead of doing this, and then you think, I'm a good modeler because I've done that. Okay, now the price forecast, what you would do is let's go over here. This would be a highly violation of our rainbow program. If you multiply this and put a plus sign and then take this one, so this is Brownian motion. When Einstein started talking about atoms and something about Brownian motion was his big deal. He took the last place you were plus then let's adjust where you are now. And when you adjust where you are now, what you do is you adjust. You first you will put the volatility in. So this, how much you can move from one uh, 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 from one space to the next depends on volatility. But then let's draw it from a normal distribution. So you put norm uh, uh, and you don't put normal distribution. Let's put a standard normal distribution. And the reason you use a standard normal distribution, that says there's a mean of 0 and a standard deviation of 1. Now, if you put random here like this, this has exactly this just takes takes the random number, which can be from 0 to 1. That's the probability. The probability goes from 0 to 1. And when you put that into a normal distribution, you get basically a number that in very extreme cases could be something like positive or negative 3. You multiply that by 33%, and then you get your number. Okay? Shift Control C. How's that? Shift Control R. Okay? And uh, uh, now what I just did was criminal. Totally criminal in so many ways. I didn't explain it. It's the inverse. You want to put the probability in, and out of that you want to get this number that can go from 1 to 3. That's the number when you have a standard a standard normal distribution. The mean would be 0. The standard deviation would be 1, and the actual value you get at is between 3 and minus 3. So if we just let's just do it like this. Let's put norm uh, uh, S inverse and put a random number. Okay, and then you'll get something like this. These ones all are negative. If I press F9 like this, I can't press F9 because of this stupid program. I have to go to the formulas and calculate. And then you can see that I just saw a number that was 2. You can see hardly ever you get a number that's either positive. Here we got plus 1.5 or minus, and then there's another 1.4. Let's keep going, and very occasionally, oh, there was a 2.6. I just missed it. Keep going. Now, the random number in the top line isn't the same as the random number in the second line. We could even show it separately. Maybe that's more of a transparent way to do it, but I'm going to leave it for now. And I was just, oh, that was a 2.5. You never, hardly ever get a 3, do you? That's the probability of getting that's like 1%, and I'm just not seeing anything. Okay. But it's fun to do. So let's stop. I'm not going to get a 3. Now, there's no mean reversion in this. This is a big deal. And perhaps let's insert a little sparkline here. How's that? So we can kind of just see what happens. Ooh, what happened to this one? This was a very extreme one. And with no mean reversion, it's a perfect example. And did I screw something up? Uh, uh, Let me go to the formulas again. No. Oops. Oh gosh. No, that's okay. I think that's okay because there's no mean reversion. This is a very good example of how important mean reversion is going to be. Okay. The price you can see up here, and are these prices always going kind of crazy at the very end? Okay, I can't I, that I don't think I made errors. It's just 33% volatility is extremely high volatility with no mean reversion. I'm going to have to change this, and I'm going to have to put 20% volatility in here. So then let's put our volumes in, F4, and Shift Control R, unlike this guy who's supposedly helping me out, refuses to, what a crime, he refuses to use my generic macros, and most of you don't anyway. I'm going to start, I have all these little sessions with people. I'm going to start demanding that they use them. Okay, so then let's put our price times our volumes in here. Okay, so we get some number. Up again. Okay, and then let's just do something very simplistic. It could be something like royalties, who knows what. We have some costs that are variable, and then we take and put some costs that are fixed. Okay, and then we can get now if we had no taxes. By the way, taxes, they're bad. You hate taxes and everything else, but taxes reduce the buffer. If you've got an income tax and you've got a really high level, the volatility will go down, and if it's a low, it's almost like a kind of a variable cost. It can be different. Uh, uh, so let's call it CFADS. That's why I was moaning about taxes, and let's take our revenues minus our minus our fixed, come on, our revenues minus our fixed costs and minus our variable costs, and let's get this. Uh-oh, oof. We still have a bad one. That would be a default. So you can see that there'd be some cases with a default, some cases you'd repay the default, and I'm going through the loss given default after this. We'll just stop here. Okay. And now let's just say for 1 minute, let's put 0 as our volatility. So now we're going to size the debt. Okay. So with the 0 volatility, let's put here our debt size. And um, let's not even leave a tail. Let's put PV of CFA. Let's put the interest rate in here first. Okay, and interest rate. Let's say the interest rate is 5%. Okay, and then let's put the PV of the CFADS. Okay, and that one. No, stupid. Oh God. See, my brain's losing it. Let's put the. Why don't I put the DSCR target? Okay, we'll leave it like that. We'll be very transparent. How's that? Maybe this rainbow program would like that. Fuckers. And then we'll put the target DSCR. The target debt service. Oh, Jesus. Okay, and let's just take that. Okay, so that's our number, and then we'll have a PV of target debt service. Now, with mean reversion, with a tail, with evaluating the project life coverage ratio instead of the loan life coverage, everything's going to change. Everything's going to change. So that's the next the next video I'm going to make. But for now, let's just put and again, what happened to my interest rate? Let's put an interest rate. These days, the interest rates are so low, it's unbelievably. But let's put the interest rate as 5%. And so we put the NPPV. Of course, this doesn't work if you've got a changing interest rate, but it's nice if you don't. So this is our in US dollars, our loan, and then let's put our loan balance. Now, when we put a loan balance, uh, uh, let's put an opening balance and put less the scheduled repayment. See, oh no! And then let's put the closing balance. Now, what we're going to do, I'm trying to, think and talk at the same time and type at the same time, which is really, really difficult for me. Uh, we're going to understand when we have a default. Our default will occur when the we have this target debt service. I almost really didn't have to do this whole loan balance, did I? In fact, let's screw it at this time. We need the uh, uh, let's put a fixed okay, let's how about this? Here's what I'm gonna do. I'm gonna be really bad. Oh, this would be such a major violation of the to have a different formula here versus here would be an enormous violation of these petty bureaucrats with petty minds. Yeah, okay, fine. I agree with that crime. I agree that that's a crime. But, you could put 5 different formulas for first year and all that stuff. Oh, God. Uh, uh, this is always going to be our debt service. So then we're going to put the target debt service right now. I'm just going to make this target debt service over here always the same. Okay, another crime in the rainbow software, so those auditors can charge you their millions. So now, if we put a volatility of 20% in here, okay, we still have a uh, 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 we still have the same debt service. Our debt service doesn't go up and down with this. I'll leave the NPV of the debt service here. That's the amount of our loan. That's the size of our loan. But if I put 1.5 here for my debt service, then we get a bigger loan, and then we'll see what kind of debt service do I have to put with what kind of volatility, with what kind of fixed cost, and what kind of variable cost, what kind of DSCR target is theoretically appropriate given the volatility. Now, for me, it's an interesting theoretical question. From a practical standpoint, maybe nothing, but it does demonstrate what happens if all of these costs were variable and none were fixed. What kind of DSCR would we need there, for example? How would that, or what happens if they're all fixed and not variable, or what happens if we change the volatility of the price? And really interestingly, will we get some probability of default somewhere around 7%, like we're aiming for here? And how do we do that? And now let's do the easy part, which is the Monte Carlo simulation. The hard part really was the getting this equation right. Clearly, we have a default here. So now let's put a default. And let's just say the default occurs whenever this is less than this. Okay, so we have a true here. Okay, and uh, if we would go even further, maybe we should put this like this. Or no, we can do it like this. First year of default. Now, what you can do now is if you use X lookup, let's try that. Our lookup value is going to be true. And the lookup array is going to be this one. And the return array is going to be up here. That's the year of the default. And then, if it's not found, let's make a default of 0. Let's make a default of 100. Okay. So if it is found, we do we want an exact match? Let's put an exact match in there, and then we want to go. I don't care. We don't care about any of this. I think we can just finish. Okay. And this said we have a default in year number 8. Okay, so there's no reason for using a match and lookup ever again with this X lookup. Okay, kind of nice. And then if I would do a recalculation, we'd have 100 here. We have no default. We have no default. We default in year 5. We default in year 3, 4. Ooh, this is so bad. We were gonna. We might need if we put a. Let's put a DSCR of 3 times in here. Okay, and then. Oops, we still have a default in year 8, 11. No, no, no default. This is going to be bad. I might have to make our volatility a little bit low because we're hitting defaults all the time. But let's work with this one, okay? I need to put 15% with a 3 times DSCR. Okay, you can see that we're going to eventually kind of hit defaults. Now this doesn't have any mean reversion. And in another video, I'm going to put in a discussion of mean reversion. Okay, I'm just seeing how long I've been blabbering for. Okay, now the last thing we need to do is we need to simply get this number. We need to just count how many defaults we have, and then we can redo our simulation with different things. Now the question will be, how many simulations, just like my pressing F9, how many times should I do that? Should I do that 100 times, 1,000 times, something else? Well, my answer is, instead of getting really fancy and mathematical, let's try it 100 times with one simulation. See how many defaults we get. And then we try it another times with 100, and we get a completely different answer. We haven't run enough. Then let's try it with 1,000 and run it 1, 2, 3, 4, 5 and see if we get the same answer. Then we can do 10,000. And it's not a big deal. So this is our little, let's make this one our little financial model. Now you notice I left a blank and all that. So let's put this into column B, and I didn't really have a sum column, did I? And we don't need a apply the top row color, I think, this time. Oops, I was doing that. Okay, and then we can show what are here. Those are our assumptions, and maybe this is our model. Okay, then you just run it again. Okay. Ugh, I gotta take that true out of there. Okay. Now let's go over here, and what I tend to do, and let's make a simulation sheet. Okay, and in our simulation sheet, we're going to perhaps let's do this. Let's put some same kind of thing, and let's put number of simulations. How's that? Simulation data, and let's put number of simulations. Now this is going to go into a macro. We're going to make a macro that just repeats. Basically, that's all. Somebody I listened to some idiotic video. I was listening to this other stuff. She said, the future, here's the problem. Loops are the big deal about any program. And we're just going to go around and around and around and around. Now you can do this with a data table too. I've seen somebody from MIT did it with a data table. But let's start with 100. Okay, and then we can put start row for output. And let's put row, and let's put the row in. How about we'll start in row 12? Okay, and that's about all we need. And then what we better do is on this default, we'll get a little table. Okay, and uh, uh, let's name this. Let's put this as our output. Okay, now there could be multiple outputs. Later we'll do this with PLCR, DLCR, LLCR, show you not only the probability of default, but the loss given default. And so, which is kind of the real issue around this. If you have mean reversion, you might have a default, but then uh, 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 you've got to be able to explain if this thing is going to bounce back. It's very different than if it's going to be forever and ever going down, like if it's a fashion or obsolescence kind of thing where it just goes down and doesn't mean revert compared to mean reversion, which is like what we saw in commodity prices. There are real economics to all of that, of course. Okay, and so let's just do this, and maybe well, how about we'll put the column start column for output. Now I've got to admit that I haven't really done this like this before. And let's say column D is a 4, 5, 6, 7, 8. J, let's make it 10. Let's put it in. So we're just going to go down to line J 12, and we're just going to make a list of of 1,000 kind of things. Now, I think what we could do is maybe click on this one, and let's call this results. Now, and what we want to do is if we make a scenario where we do 100 versus 1,000, we want to be able to delete that. So you don't want it always to be the same. So let's go to a developer and just make a new macro. I wish there was, and perhaps there is something up here to do this. I wish there was a way you could automatically have it go to this workbook. There probably is. Somebody might be really nice and send me something. One of the one people who watched the video and I'm going to call it simulate. And it's about the easiest macro you could possibly create. Okay. Uh, uh, let's kind of put it next to this one, I suppose. And all we're going to do is we're just going to go around and we'll go for, how about simulations? No, how about for that's the name of the sheet, for iterations equal 1 to um, how many rows? Number of simulations. And let's put range uh, number of simulations. Okay, that's all that's going to do. And what we need to do then is just, how about let's just cheat on this one, and then let's copy these ones too, just temporarily, and let's make them range names. Shift Control F3, and since I have my silly little kind of HP thing here, I can't. Shift Control Function F3. Okay, we don't want the top row, we want the right column. Okay, and let's save that. Oops. Okay, yeah, I'm gonna save the file. Okay. And this will be somewhere. No, we don't want it to be a macro-free workbook. We want it to be a macro-enabled workbook. Okay. And then let's go and do this. Okay. And so what we're going to do is then in our, let's put cells. So, and this is just like an index. We put cells, and the row is the iterations. And it's, I'm kind of making it harder than we really have to. But we can start with start row for output. What a crime I just kind of did. Although that silly little thing wouldn't say that. Those assholes at Rainbow, they say, oh, you can't have too many VBAs. What a jerk. And then for the column, we put range, and then you just put start. And again, you could just put 10, 10 or whatever. Start, column, and it doesn't, the caps don't matter. It's not case sensitive. Okay. And then I need another one. Oops. Cells. Did I have it? No. Equal range output. Remember, I call that. Okay, that's our only thing we really need. Okay, and to before we start with this, why don't we put up here results? Let's make sure that one is equal to is cleared. Clear, how about we'll just clear everything? We could clear contents. Well, just in case, let's clear contents. Okay, and then let's put next, and I should call it iteration. How about that? So what should happen is basically that is all you need. Okay, and so let's put a button in here. Okay, and click on the simulate. Okay, and I'm good. We'll just try it with 100. And of course, I did it wrong, and I didn't. Iteration. Oh, I forgot the S here. I made that mistake on purpose. Okay, and then we count from there. We count that does 100 iterations, which isn't very much. And then the first thing we can do is we can put if this is, and we've got to make sure that the thing goes all the way down. But if this equals 100, then we have a false, otherwise true. How's that? So then we have no default, otherwise we have a default. So we defaulted in year 100, and now what we could do is just put up here simulation results. Now we have to be really careful. We'll put number of defaults. Okay, and just put number, and that's just a countif. Okay, whoops, countif, and then we can just click on this entire thing. That for me, that's what I would do, and count when it's true. So we have 54 defaults, and this is really bad. So our example is not, my example is not working out. And what I'm going to have to do is I'm going to have to make a radical reduction in the volatility or in the fixed costs. So I'm going to put the fixed cost down to 0. Let's try it that way, and then let's just run it like this. Why not? Okay. And then probability of default. Oh, very interesting. Isn't that interesting? The probability of default went all the way from 40 to 16. Understanding what's a fixed and a variable cost is a really big deal. I think it is. Maybe I haven't proven it to you, and maybe you can argue about it, so I don't want to get completely obsessed about it. And then let's change the volatility to 10%. Okay? And then let's rerun our simulation. And okay, now we have a 1% number. And then what we could do is we could just change our target DSCR and say, no, if we only have volatility of 10%, maybe we can take a 1.5 DSCR. Maybe the whole thing works with a 1.5 DSCR. Okay, and it doesn't look like that's going to work very well. Our DSCR was way too low. Let's put a let's put two times. Let's put the volatility only to be 5%. Okay, and put a different volatility. Maybe I went too low. Now we've only got 1%, which means we only have one single. We only have one single default in the whole thing. And obviously, when you're dealing with these kind of numbers, that would be crazy. So let's get a little more precise. Let's put 1,000 here, and I'm gonna probably have to start with uh, uh, you know, pausing this. Okay, so let me see. I Is this true? Was it that rare? The last one we got absolutely no defaults. Ah, what a kind of waste. I did it all the way down to 1,000 and I got no defaults. Let's put a DSCR of 1.5 into this, okay, and do it one more time. And it's going around and around. I've got to. So I'm almost about to stop. I've got a scenario here with 1.5 times DSCR, and remember, Standard and Poor's said, well, for a triple B, where did they say this? This is our ratings, our PD by year. Okay, it had our we had 5.4%, and then they said, well, for a triple B, a flat triple B, it's about 4.79 in year 15. And that's the kind of number we achieved. Now, what I should do is do this again. And if I do this again for 1,000, it'll probably give me a different number. So maybe I should try 10,000. Okay, I'm not gonna I hope you can kind of see it from my example of 100 or 1,000, and that demonstrates. It does demonstrate that these are the key things that really do drive credit. But the problem is you don't know really what the volatility is, and once we put mean reversion in or a different non-normal distribution, we're going to get an entirely different answer, and I'm going to keep going with that. I'm going to talk to you about how to measure mean reversion and how to model a mean reversion. And it's a very academic thing, but I've been working on such boring practical crap. I want to do a little of that just so you can think about things. Now, the other thing we can do is we can get the over here, we can get the here are defaults. We can see what year the defaults have occurred. So uh, we had 54 defaults, and let's see if we can get some kind of simulation of the year of default. And I'm going to pause the video for just a minute. So why don't we try this? Let's put the year if default. I had to think about it a little. And let's just put up here, we'll go up here and put a add only when it's true. We happen to do that. So we've got 1, 2, 3, 7. Okay, and then now let's go over here where we have the default year, and let's put let's try this. Let's try X lookup again. I'm just trying to get used to X lookup. And click on that default year, and then let's click on this one. Okay. And this would be not allowed by Rainbow program. Oof. And then the return array is going to be this. Okay, so far, so good. And then if not found, let's put false. That's like instead of NA, that's very helpful. And I think we need an exact match. Okay. And let's see. Yes, so look at this. Number 1 was 13. Okay, and let's find number 2. Watch it still be 13. 2 is 13. And let's find number 3. This is almost like a video about X lookup. 3 is 16. A 4 is 7. Okay, and that seems to have kind of worked. Okay, and then I didn't have anything after that. Okay, so year, and now let's just accumulate it and see if we can make a graph. And I'm going to have to pause again. Okay, so now let's so I put a small command. Small. This is kind of illegal to, I'm sure, the people, because it apparently can slow down Excel a little bit. So you take the whole thing, press F4, and do this. And what that will do is it'll just give you the smallest to the largest. And it kind of gives you 2. So that let's see if there were 2 sevens. There were 2 sevens. And then it gives you a num. And this is another illegal thing. You're not supposed to use if error that by those auditors, because they say if you use if error, you can just be hiding some kind of error in your sheet, and you should show your errors. Screw that. Let's put false again. Okay, so now we are almost finished, I think, because we can see kind of when the defaults are occurring. All right, and then we can go over here. Let's go over here and make 1 to 15. So let's do it with a column and go to 15. How's that? And then we can put, for each one, let's put count if. Will that work? Count if, and we put the, we'll click on this one. Luckily, there's nothing there. Of course, that would be another illegal thing to do. All right, screw that again. And we count how many defaults have occurred for the different years. Okay, so this is the count, and then and perhaps this would be much better with 10 or 15,000 and all that, and then we can put the probability, and that's just this divided by our number of simulations. Okay, and that's our amount, and then we can put cumulative. Again, another illegal formula because it's not. Oh shit. Uh, um, and then we can kind of just. Uh-oh. Why did I not get the total amount? Just let me pause. But I'm just looking at this. It should have accumulated to our. Okay, I forgot. I apparently made a 20-year model. And up here we have 20. Uh, we have it up to 20 years. Okay, and so now that correctly gives our simulation, and I suppose I'll make a graph. So our graph. When we did our volatility like this, when we didn't do any mean reversion, the long term, if it's a long term loan, it's really increasing the probability of default. And I don't know. For me, this is a little bit interesting academically. It theoretically, you could say, well, is should I put, the banks have to put in with Basel, my wonderful city. See, that's where I'm really from, is Basel. I swear I am. When they use Basel IV or something and they put more capital, if this was just really, if the volatility didn't have any mean reversion, the risk does go up over time, and we can illustrate these things. Now, I'm very afraid of all these volatilities I put in, and the fixed and variable costs and all that, because this is just part one. This really is just part one. We're gonna do some more, a lot more, and maybe nobody will watch it, but at least it gives me a chance to get away from the rainbow program and auditors and all this crap that I'm going crazy with. And so that's the end of